Okay, we'll get started. Today we'll continue our discussion for AP Computer Science A review, okay? We are going to look into the object class and object-oriented programming, okay? Let's see, the volume is low, let me see. Let me check my audio. Hear me? Can somebody say something? Hear me?
We can hear you.
Okay, thank you. Okay, we'll get started, okay? So we'll combine them together because some of the topics are shared. Week 4 is object-oriented programming. So we'll get started from here, okay? So we'll get started from here, the object-oriented programming. First one is the overview of the object-oriented programming. The first thing is testing, okay, testing. Now this testing diagram actually is related to how you answer the FRQ, okay? This week so far, I only see about 5 or 6 people who actually return the weekly practice problem, okay? So far, probably 6 people already returned it only, okay? And also the FRQ 2011, only 2 people returned, okay? One thing I need to announce is that this 2011, there are some Greek word problem. Please, you can skip it, okay? So if you see some problem that is actually Greek word problem, please skip them, okay? Because we are using the College Board practice set, and 2011 to 2016, there are some Greek word problem, but that was discontinued in 2016. So basically, if you see the word Greek word problem, that FRQ problem, you can basically skip it, okay? It's no longer tested. It's some sort of AP computer science lab that was actually used maybe 6-7 years ago. So they will not be tested now, okay? So you can take them out, okay? That's number 1. Number 2, please submit more, okay? Right now, actually, the return rate is low, so we cannot see how good you are and then cannot give you some suggestion, okay? So please return more. So now first thing is like, when we test a program, you need to think about the precondition, input value, post-condition, and output value, okay? So let me bring up a College Board set, okay? Let me bring up a College Board problem set. So let me use the 2011 one as an example, okay? So let's use this problem 2011 set as an example. So every time you work on this free response problem, okay, free response problem, you will see some description for the problem. So this portion is just briefly go through it because there are so many things that you actually need to cover. So you pretty much need to know if you need to answer part A is over here, okay? Part B is over here, good enough. That's roughly, you know that there's a class called sum, there's an array of samples. That's what you need to learn. Then you move on to the problem statement. So problem statement is here, you have the A, this, okay? So read through it. This is your problem statement, and then you need to solve it and give the answer, okay? So this portion we know. You need to work on the problem and then you need to answer it. But one very important part is this portion. Above the function, you should see some parameter, return value, precondition, and sometimes also the post condition. Okay, sometimes also the post condition. Like in part B case, you also had a precondition, post condition. Okay, so basically, the so-called parameter would be the input to the function. Okay, so the parameter will be the input to the function. So if you see the parameter is the description to the input to the function. Output would be the return value. So the return value is your expected result. Okay, your expected result would be something like that. Okay, and then inside here you should also check what is the precondition. So precondition sometimes like this. Sometimes say that, okay, I have an array. Okay, I have an array. So array, maybe the precondition is that the array length is greater or equals to 2. So then you don't need to reconsider the array length that's only 1 or 0. Those kind of precondition you do not need to worry about. So that's a precondition. So precondition is a condition of your input value. When you try to write your program, you do not, you actually need to check your precondition. Okay. Post condition is like when you generate some return value, it must meet the post condition. Okay. So these are precondition and post condition. You must make sure that your software you have written meet the requirement for the post condition. Also, take advantage of the input preconditions. Okay. And something unexpected, we call it side effect. Okay, something unexpected, we call it side effect. So we try to reduce the side effect and actually try to meet the post condition as much as possible. Try to use the precondition as much as possible. That's what we actually know about the testing of the program. Okay, so here you do have some precondition and post condition. Once when you work on this problem, please look at these more carefully. But you should read your problem statement first before you go back to check what is the precondition and post condition. And then after you read the precondition and post condition, decide how to solve the problem. Okay, and then think about your algorithm, and then you type in your solution. Okay, maybe draw some diagram or do something before you really do coding. Okay, so that's the suggestion, and that is the software testing portion. Okay, so today we are talking about the object-oriented programming. So object-oriented programming, there are 3 major topics, that is encapsulation, inheritance, and polymorphism. Okay, there's another one called abstraction, but abstraction actually really is very simple and it's not unique to the object-oriented programming. Function also have functional abstraction. Procedure also have procedural abstraction. So object-oriented programming is only one example of data abstraction. Okay, but object-oriented programming by itself has encapsulation, inheritance, and polymorphism. We will explain these 3 terms later. Okay, so here these are the different topics that is covered in the AP exam. Okay, the gray area is not covered by AP. Okay, blue one are covered. Blue one are something that you will be tested. Okay, blue one are something you will be tested. So you need, okay, interface and object class are taken now in 2020. So these are not covered. So you need to know about what are class, what are object, what are static functions, static variable, what are constants, what are container and the function. So this term you need to know. And then you also need to know about the visibility, including public, default, and private, protected, not tested. Okay. And then encapsulation, you know about the concept of encapsulation, wrapper class, and immutable of the class. Okay. And relationship, you need to know about has a relationship and is a relationship. Also, this keyword and super keyword, these are something you need to know. So all these we'll go over it, okay, this week and next week. Okay, we'll all go over it this week and next week. So this week we will more focus on this portion, the class and object portion. Okay, next week more on this portion. Okay, but we will spend 2 weeks on here. Okay, it is week 3 and week 4, but I use a week starting portion of the week 4 to explain what will be covered in this 2 weeks for the review. Okay, so then we have the polymorphism. Polymorphism will be tested overloading, overriding, deleting, binding, and polymorphic method. These are all tested. So you need to learn all of these different topics. Okay, we will cover it one by one. Okay, so let's get started. First one is you need to know about reference data type. Okay, reference data type. So here, Java has different data type. Some are primitive data type, some are non-primitive data type. So primitive data type, you have Boolean, char, integer, and double. These are 4 types that will be tested for the AP ComSci A. Okay, let me ask a question. Okay, these are primitive data type. An array, class, and string, these are called reference data type. Okay, before I explain it, let me actually check somebody to see if you know it. Okay, this time let me get him from the bottom of the list. Okay, first one, let me ask William Zai, right? William Zai, and what is primitive data type? Do you know what is primitive data type? This one for William Zai. GHAI. Hear me? Hello, William, hear me? Hear me? No response. Okay, let me try second one. William Lin, okay, Lin, another William. Hi, William Lin, hear me?
Yeah, I can hear you.
So what is the primitive data type that you know?
Boolean, integer, float, double. I mean, they're all listed there. Yeah, and character.
I talked about it already, but what does a primitive data type really mean?
Oh, I'm not sure, but I'm pretty sure it has something to do with like the size and like the bytes of the data types.
It has nothing to do with the size. Okay, let me try another one. Oscar surrenderness. Okay, sorry, I don't know how to spell your last name.
Primitive type refers to like a single piece of memory, or like it's like a really like more of a smaller quote unquote type of data, but like a non-primitive data type is sort of like a class. Basically.
Yeah, very good. Okay, primitive data is very simple. When you declare an integer A, that means that you allocate some memory location and put some data into it. That is primitive data type. Okay, that's a primitive data type. So this one is like this. So it declares something called integer 100 equals 100. Okay, so when you declare integer 100, you allocate some memory location and you put a 100 into it. Okay, the address is this. So this one is called primitive data type. Okay, so primitive data type means that when you declare, the data and the value will be the value will be stored in the memory location that you assign. That's called primitive data type. Okay, so this one is primitive data type. Now let's look at the other type that actually is reference data type. So reference data type, we have the class, we have string, we have array type. Okay, these 3 data type has the same feature of being flexible length. Okay, or too long. Sometimes it's too long. Okay, for example, you may have an integer of 0. You may have integer array of 10. You may have integer array of 100. So basically, you cannot allocate a certain memory and then actually put everything into that memory location. So we cannot use a primitive data types idea to store the array. We cannot. Okay, we cannot. So they invented a different way to store it that is called reference data type. Okay, so this reference data type actually is when we do this, we will do string, okay, str equals hello. Okay, so here we create a hello in some dynamic allocated memory area. So the address say is 240713. Okay, So that can be 5 character, can be 10 character, can be 200 character. We don't know, but it is a string. So we actually allocate into some dynamic memory. Okay, we call it heap. We call it heap. And then your local variable str does not hold the value of the object of the string. Instead, your str is holding the address that pointing to there. So you put 240713 to that. Okay, so it's different. The primitive data type, you hold a value, while reference data type, you hold the address. So these two are totally different. Okay, these two are totally different. We hold the address because we don't know what is the size of your string. You need to use a length function for string to figure out. You need to use a length constant to the variable to figure out, or you need to use size to figure out. Okay, for array list. So that is sometimes you need to use a function to figure out how long it is. So basically, you store your data in the heap. Okay, in the heap, and then you just put the address into your variable. Okay, and this one you will show you will see how this is important, why this is important when we review the problem. Okay, you'll see why this concept is very important. So right here, the first thing is that you must know about what is reference type. So your class, your string, your data array, they are all reference type. So reference type is very simple. Let's create a program. Okay, so that's called test reference type. Okay, so that's called test reference type. So here, actually here I have public. Okay, edit. Okay, void in. Okay, if you have question, you can voice out. Okay, if I need to check the checkbox, it takes time. Okay? I may come back later to check it. Okay, so if you have question, you can directly voice out. I can be interrupted. Okay, don't worry. I can be interrupted. So here, say I have a primitive data type, so have an a equals 3. Okay, so basically this one is creating a memory location. You put 3 to there, and your a is pointed referencing to it. Okay, so a is associated with that memory location. So now let's assume that we have an array, and this array is integer ARY array equals 1, 2, 3. Okay, 1, 2, 3. So we create an array. So this one is different. So if we have the primitive data type and you try to print it, okay, you try to print it and print A. Okay, so this one when we print the value for the variable is 3. Okay, now if I have an array and I try to print this ARY. Okay, I print this ARY. This ARY is actually a reference data type. It's an array. So when I print it, I will see something like this. Okay, what does this mean? This means that it actually is I is integer, bracket is array. So it is an integer array at this location. This location actually is the address. So what it really means is that your ARY really store 79F791AB. That's the address. That's pointing to somewhere that you have the storage of the data that's 1, 2, 3. Okay, that's your integer array object. And we call this one ARY as the array reference. Okay, so reference data type means that your variable is only a reference, only saving the address. And the object you refer to actually is stored somewhere else. We call it object. So object and reference, one is address, one is the value. Okay, one is the storage. They actually are separate. Okay, for the reference data type. While your primitive data type, you actually have A, you store a 3 in there, and it actually is done. Okay, let me take the problem from set. Okay, let me see. Okay, let me see co-host. Let me try. Okay. Doris, let me try later. Yeah.
Thank you.
Co-host. Okay. Let me see. Okay. Let me check. Meeting information. Okay, let me see. Okay, I'll set it after class. Is okay for all of the other session. Okay.
Yeah, no problem.
So here, do you have any question or suggestion?
No, I will require and remind everyone to turn on the webcam so I can make sure every student's here.
Yeah, okay. So Doris, one thing is that in the middle, you can, if you have suggestion, you can just directly say it, okay? Don't really worry about me. I'm okay. I'm interruptible. Okay?
No problem. Thank you.
Just go ahead and actually say.
Thank you so
please
much.
turn on your camera, please. Okay, for everybody, please turn on your camera, so we will know that what are you doing. Okay, make sure you don't fall asleep. Okay. Okay. Any questions so far? So these are some concepts. You will wait until you see the problem. You will know why we need to teach you this reference and the primitive data type. Okay. So basically, this is a very important concept. Before we talk about object and class, we need to know about three types in Java. They are reference data type, class type, string type, and array type. Okay. Very, very important. Very, very important. So here, if you have a regular data type, it will be stored in stack. Okay, stack actually is for local variable only. It will be stored in stack. Okay, so say you have A store 3. This is actually primitive data type. If you are a reference data type, you will actually store the address 79 something pointing to the heap, the dynamic area. And dynamic area, you store 1, 2, 3 over there. So that is an object. Okay, that is an object. And then this one only is the address pointing to there. Okay, so the primitive data type and the reference data type, they are different. They are actually different. Okay, they are different. And remember the stack and heap. We have 3 types of variable. We will cover it pretty soon. Okay, we have 3 types of variable. You must remember where are the variables stored. Okay, very important. So now we can have a declaration of a reference data type. So person is a class. Person type and P1 is a reference. So this one declare a reference. It really declare a reference variable. You create a storage, but that's only to store the address. Okay, but you knew a person is a class object. You will store somewhere else, and that address will put into here. So here, this one is declaration and then instantiation. Okay, and let's actually try this one. Okay, let me actually try by using a program to explain it. So let me create a very simple class called point. Okay, let's create a very simple class called point. So this point is a class. Okay, this one is a class. So this class right here, we have integer x and integer y. Okay, so if you do not specify value, initially this x will be set to 0. Okay, if you do not put x equals 0, you automatically give you a 0 there. So this one is actually automatically. We will talk about it later, how different type will be set to what. So here you have a point. A point is a 2D data point in your 2D XY space. You have point called XY. Okay, so you have data like that. So we create a point like that. Okay, we create a point like that. Then we may need to have a constructor. So this constructor is point. Okay, and we have x and integer y. Okay. Okay, and then here you have a integer x, integer y. This integer x, integer y is different from this integer x and this integer y. Okay, these two we call them parameter. These two are instance variable. These two are different. Okay, these two are different. These two are instance variable. and these two are actually called parameter, okay? But they have name conflict. They have name conflict. So right here, I need to use this dot x equals x. This means this object. So this points x. This points x will be equal x, okay? And this points y will be equal y. So the purpose of this constructor is to initialize the value of the xy for the point, okay? So this one actually we create a class, okay, with a constructor. Constructor is to build the object and assign, okay, assign value to it, okay? So this one we actually has a constructor. Let me finish one more function and we will get out from this class. Okay, so here we have another one called TwoString. So TwoString function actually here will return, okay, return bracket, okay, parenthesis, plus, okay. And here we have quote, okay, here we have x plus, here we have comma, okay, comma. And then we have a y, okay, over here. So we have the TwoString. So this one is a very, very simple class called point. And we can test this point. So we write a test point class to test it, okay? So this test point class will test the class of point. So class is a template of object, okay? It is a class. So the purpose of the class is that we can use that as a data type. So right here we create something like this. Okay, so shoot that out of point. Okay, I'm going a little bit faster than normal because this one we are in the review class, not a regular school year class. Okay, so if you don't know something, please just voice out. Okay, please just voice out. So right here I have a point p1 equals new point. Okay, and then 3 and 4. Okay, 3 and 4. So here I just do one thing, system.out.print line, print out my p1's x and print out my p1's y. Okay, that's it. So I create a point. So at this moment, what we do is actually we create a pointer p, okay, and that actually is a reference variable. It store the address. It store the address and it pointing to the heap. And the heap there is a point data with 3 and 4 waiting for me there. Okay, so I try to print x and print y. Okay, so with these two functions, with these two statements, I'm going to print out the data. That will give me 3 and 4. Okay, that will give me 3 and 4. So basically, I print out two data fields, and these two data fields is this x and y. So right here, if I don't use x and y, I do not use this dot x and this dot y, I have the name conflict. At this moment, this x means this x. This x also means this x. So 3 ray x are the same. At this moment, the 3x are the same. So these 3x are the same, and then we print it, you become 0, 0. You become 0 instead of 3, 4, okay? Instead of 3, 4. So here you see this variable x actually is also this variable x. These 3 are the same. So in order to differentiate it, either you use a xx here, yy here. So different name. Different name is okay. So when you have different name, this xx means the SS here, YY means this YY here. But now this X is no longer the red X. Now this X become this green X. So if there is no conflict, this X is the instance variable X. If there is a conflict, then that means this local parameter X. Okay, so that's one thing you need to know. This one pretty open, it will be tested. Okay, it will be tested period. You see it right here, it becomes 3 and 4. Okay, but to be safe, usually I don't write this way. Usually I just say this object's x equals x, this object's y equals y. Okay, so here I actually make it this way. Okay, and I print it. Okay, as I got the 0, 0. Okay, Now, so I can print these two data field. Okay, so here I actually may do system.out.print line, while I print line my P1. Okay, I'll print my P1. So print this P1, actually, you print out this object, okay, you print out this object. Assuming that I don't have this TwoString function. Let's assume that we don't have this TwoString function, okay? So I comment this TwoString function out, okay? So if I comment this TwoString function out, and then I print the P1, you give me the class name, the point object at this location, okay? So pretty much it actually print out my P1 is holding the address of 608075337, that pointing to somewhere, and they have the data of 34. But I cannot see the 34 because I do not have a TwoString function. Because I do not have a TwoString function. So this TwoString function must be turned on so that you actually will convert the object or the reference type into a string. So the string will automatically convert your object to a string. You become 0, 0, okay? So right here, let me see. Let me actually compile one more time, okay? And let's run it, okay? How come it's 0, 0? Let me try one more time. This one is P134, okay?
Point in the point class, you forgot to make XX and YY back to X and Y.
Oh, okay, okay, sorry, yeah, sorry. I forget to turn them back. Thank you. Yeah, sometimes here is mistake, okay? Any questions so far? So that's the power of the TwoString function. Okay, that's the power of TwoString function. So to build a class, you need to actually write this the so-called instant data field. Okay, the purpose of writing a class actually is creating a new data type called point data type, and this point data type is a collection of two integers, one for x, one for y, to represent a point. Okay. And you basically use that as a data type, and it is a reference data type, so you can create a pointer and pointing to the object. Okay, you can create a reference that pointing to the object. Okay, so now this one is the so-called class. So right here, let's assume that we don't have this constructor. Okay. We don't have constructor. So if we don't have constructor, then we will get a default constructor that will be point, parentheses, and do nothing. Okay, this one we call it default constructor, but we comment it out. Okay, we comment it out. So at this moment, there's no constructor. Okay, there's no constructor. So there's no such thing as 3-4 constructor. You can only have a default constructor. So you run default constructor and you will get 0, 0. Okay, you get 0, 0. So at this moment, you cannot initialize the value of x, y. You only get the default value of 0, 0 over there. Okay, so you cannot say. Then you actually can define this constructor to fit in the data to the object. Okay, so you create this one and you actually compile. Okay, here we can put 3, 4 into that. But because I comment out the no argument constructor, so right here, when I try to have no argument constructor, the default constructor already been overwritten. So I only have this 2 argument constructor. So if I don't write anything, I'll get the default constructor. But if I write something, the default constructor will be gone. Okay, so I no longer have the no argument constructor. So at this moment, if you still want the default constructor, you need to write a separate default constructor in order to make it work. Okay. Okay, in order to make it work. But usually we don't like this. We actually usually will put some value to it to initialize it. So here, this one is the so-called constructor. Okay, so constructor is to set up your initial value. So right here we cover what is no argument constructor, what is with argument constructor. Okay, And this no argument constructor is exactly the same that you use this to initialize the value. This means that you are calling this constructor. Okay, it's the same as this. Any questions so far? Hello, any questions so far? Hi, Amy Zhao, any question?
No.
No question? Okay. So these are the constructor, okay? So now we finish constructor. The next one actually is getter. So now you have a point, and sometimes you may have a function called public integer, okay, get x. Okay, get x, your return is x value, okay? And this, we call it getter, okay? These two that we sometimes call it getters. Okay, sometimes we call it accessors. Okay, getter and accessor is to get some value or some data field. Okay, so right here, if we make this data as private, okay, as private, so that's assume that we make this data as private. Okay, so private is a data field that other class cannot see. So at this moment we compile and it no longer works because this XY cannot be seen by other class. So you are not able to see the XY now. You cannot print it now. So you have to use a getter to access it. So here we need to change it to get X and get Y over here. So here you need to update to such getter function in order to get the data. Okay, now we get the same data. Okay. So let me try 5 and 6. So now we know that it's actually a new function being used. Okay, so here we would have a getter and getter function to get the data for the two data fields. Okay, we have the getter function for the two data fields. Okay, next one is mutated. Okay, mutated also known as setters. Okay. This one is mutated, okay, mutated. So mutated, we have public, okay, void function, okay, we can set X, okay. So sometimes you want to update the data. So you can actually use XX. So right here, I use XX. I can also use X and do list that X equals X, okay, but I try to use XX. So this X equals XX, okay. That will set X, okay. And I can also set Y, okay. I can also set Y, so I set YY, okay. So my Y will be set to YY. So this one is a setter, okay. So setter sometimes also call it mutator. So when in a problem you see the word mutator, that means it actually is the setters, okay. So setter will change the data. Accessor will not change the data. Okay, these are the difference. Okay, these are the difference. So setter, you may change the data. So that right here, let's actually try after this. Okay, after this, let's do P1 that set X as 10. P1 that set Y as 20. Okay, and let's actually print now my P1 again one more time. Okay. Okay, so I'll print 1020 this time. So the data of the XY now already being changed using the mutator. Okay. So here you see, I'm trying to build a class, okay, build a class. So there's a instance data field, constructor of no argument, one argument, two argument, okay, getter, setter. Next one, I may also have the equal function. So equal function, remember that you should return the Boolean value and you use equals, okay, you use equals. So let's assume that we don't have equals, okay. Let's assume that we don't have equals. So when we don't have equals, let's assume that we don't have equals. And here I have the point P2 equals new point, okay? And then 10 and 20. Okay, these 2 points, suppose they have the same value, okay? They have the same value. So here I do system.out the print line. Okay, I'm saying the P1 equals P2, okay? So P1 equals P2, so I actually compile and run, it actually got false. Why is that? Why is that? Because your P1 is creating an object. It say that's assume that its address is H5. So it pointing to an H5 location is at 10 and 20. Okay. P2, let's assume that its address is A10. Okay. So A10 pointing to another location is at 10 and 20. Okay. So when we compare using double equal sign, they are comparing the address. So the address is different. So this one is false. This one is false. So comparing the address, this one is false. So here let's assume that we have point P3, okay? It is equal P1, okay? This one actually, we copy and test P1 and P3 now. So this one will become true. This one will become true. This one becomes true because what? Because my original P1 is pointing to 10, 20. Okay. My P2 pointing to another object that's also 10, 20. Okay. Now my P3 actually is assigning the address of P1 to P3. So P3 also pointing to the same object. Okay. Also pointing to the same object. So what? So I get true when I compare the address. These two holding the same address. Any questions so far? Any questions so far? So double equal sign compare addresses. Okay, remember double equal sign compare addresses. When you try to compare two objects reference, they are comparing addresses. Okay, wait, but we do need to compare the content. I want this P1, P2, P3 to be the same because all they are represent the same point of 10, 20, right? So how to compare the content instead of comparing the address? Then you need to override the equals function, okay? Then you need to override the equals function. So right here, that's assume that we did not override the equals function. So we did not override the equal function, and right here, let's actually do one more time, copy these two, put it over here, okay? We did not override the equals function. So here we do P1 dot equals, okay, P2, okay. Also P1 dot equals P3, okay. So we try to compare this. This dot equals, okay, dot equals will compare the content, okay. But at this moment, this dot equals function will not compare content because what? Because the equals function is defined in object class. And at this moment, it will still be using the double equal sign to check. So they are still false and true. So that's not enough. So you must override this one to compare the content. So here we would have a object type, okay? Because the equal function defined in the object class, so you need to redefine it as an object, okay? But now you will actually convert it to another point. So here we have point dot. So this point dot will be casting from the object class object to dot, okay? And then we will return, this dot x equals dot x and this dot y equals dot y. So we compare the content of the two values. Okay, right here is not object. We need to change it to point type. Okay, so we convert the object type data to the point type, and then basically this one is okay. So now we run the equals they will compare the contents and it become true, true instead of false, true. Is that okay? Is that okay so far? So I go over the basic class construction. Here you have a private data field, you have constructor, you have getter, you have setter, you have the so-called equal function and TwoString function. One more, okay, one more. You may have a derived data field. Derived data field such as norm, okay, norm of this vector. So you return, okay, mesh that square root of the x times x plus y times y. Okay, let's call it norm. The norm is defined as your vector format. You have the xy point. So the length of this guy to the original point, 0, 0. This one we call it norm of this vector. It will be square root of the x squared plus y squared. So that's the norm. Okay, that's the norm. So this one, it is considered to be a getter as well, but it actually sometimes we call it derived data field because it looks like a data field, but it's like a get x. You get something. Okay, you can also name it get norm. Okay, you can also call it get norm, but it's usually calculated based on the data you store. So we call it derived data field. Okay, so we call it derived data field. So right here, this derived data field, you can also print it as system.out, the print line, or the p1.norm. Okay, you call the norm function and you compile and you run it. Okay, so that's the norm. That's a square root of x squared plus y squared. That's your norm. Okay, so here we have norm. We have this different data field. So sometimes you may also have some constant. Okay, some constant. So you can also say final. Okay, static. Okay, integer. Okay, kept. So kept 100. Okay, so you do not allow the object to create more than 100. So you set a capacity that you can allow. So that is a constant. So constant is a final data. It is static. It's static because it's a shared data. Okay. So here let's look at a static variable. So we can also have a static variable, say number of points. Okay, number of points is actually a static data. So initially it's 0. So every time we create a new object, the number of points will increase. Okay, will increase. So let's actually copy this one to here. Okay, that's the number of points. So this one is static data. Okay, static data doesn't belong to any object. Okay, doesn't belong to any object. So right here, before we print out, we actually create the first object. Let's actually do point. Okay, it's a class variable. It's a static variable, so it's shared by everybody. So number of points, we can print it here. Okay, and after we create it right here, we actually will print it once. Okay, and after we create a second object, we will create one more. Okay. And then here we actually copy the reference. We will actually also print it once. Okay. So this one will not increase. This one, the number of pointer will not increase. Only when you run the new function, running the constructor, you will increase the number. So let's run it. Okay. So the first one, your number of the point is 0. Here you got a 0. Okay. And after you create the 5, 6, you get one object. Okay, one object. And then after you create your 10, 20, you get 2. Okay. And then after you copy the reference, the number of points doesn't increase because you only copy a reference. That one you did not create a new reference, a new object. So the number of objects remain 2. Is that okay? Any questions so far? Okay, right here, let's have a 5 minutes break. Okay, come back on 6:30. 6:55. Okay, right here we finish the basic class construction, so that actually come back on 6:55 p.m. We will continue for other topic. Okay, so right here we finish the first part about what is class and object. Okay, come back 5 minutes later. Okay, any questions so far? Let me put the file I have into the chat box. Okay, so you can look at the program if you are interested. Okay, let me put a file into there. So the point class, okay. The test point. The point class and test point. And the test reference. Any questions so far? Hear me? So Henry, you have any question? Hello?
No question.
Doing okay so far?
Yeah.
How about Luke Mar? Do you have question? Okay, let me know if you have question, okay? So here we go over the basic rule for the class. Why this is important? Okay, this is very important because remember, let's actually go back to last week. Okay, last week when we talk about the review strategy, okay, when we talk about the review strategy, okay, we talk about the review strategy. Class is very important. Class is very important because there is a Q2. Q2 of the FRQ is always to write a class. To write a class, you must remember what is needed to write a class. So right here, I quickly go over the basic class. It's not complete yet, okay? It's not completed yet. We will continue to use this example, but it's not completed yet. But you need to learn all of the class writing skill. That's one FRQ problem here, okay? That actually is one of the FRQ problem here. So here we do go into this test point, okay? Looking at this different things you need to have. Number one, you need to look at what are the constants, okay? So they are constants you need to define in your class, okay? And then you will need to define your instance variables, okay? And then you need to define your static variables, okay? And then you need to define your constructors, okay? And then you need to define your getter, setter, derived data fields, and then you also need to define your overridden methods, okay? Overriding the method from equal object class, okay? And there are some other important overridden method. We may talk about it later, okay? So these are like that, okay? So we may also have sometimes have static method. So here let's put some static method here. So static method. So static method usually is what? Doesn't belong to any object. So here say we may have a static method called a public, okay? Here we will do what? We will do static, okay? Print, okay? This print function, okay, so this print function will actually is a void type, and we can print, okay, print. So this print function will print certain point, okay. So let's assume that this point is called P, okay. We'll print certain point, so we will deal with this P. We pass the P into here. We're going to print it. So we do what? We do system.out. Print f, okay, print f, and we had a formatted string, so we say point, and then %d, comma %d, okay, and then here backslash n. Okay, here we may put your p actually p.x and p.y. Wait, isn't that you have the private data field? How comes that you can actually use a print function to print it? And it's different object. It's a p object. It's not a current object. That's because that this print function is located in the same function, in the same class as point. So that actually is legal. That actually is legal. Okay. So this a print function provides a service for any point. Okay. For any point. So this one, if you want to call this print function from my test point function, so right here, then I need to use class name point the print. Okay, task to point the print, and I print out a P3. Okay, so this one is print out a point P3, but it's a class function, so I need to put class name dot method. So you need to put class name dot method. Okay, method name. And then with the parameter, and you print it. Okay, you print it. So that is the static method, your class method. So static is shared property, and it when you call it, you have to you have used the class name that method to call it. Okay. Okay, so that's the class method. So here, one thing let's actually review a little bit. Okay, so here let's look at what is class variable and what is instance variable. Okay, so you have a point, right? You have point. You have point class. You create a P1. You create a P2. P2, and you also have P3. Pointing to the P1's location. Okay, so that's what we have so far. Okay, that's what we have so far. And then you have a number of points. So number of points is a shared property. So it belongs to the class. It doesn't belong to P1 or P2. Because that's a total number of points being created. It doesn't belong to P1. It is not a property of the P1. It's not property of P2. It's not property of P3. Number of points is a shared property. Okay. And this print function, the same. Print function doesn't belong to any object. It is helping to print any arbitrary point P. So that actually is a shared property. When a shared property, we use the word static. And static means class variable or class method. And that really means shared. Okay, really means shared. Any questions so far? Any questions so far? How about Lin? Lin Pen, are you okay?
Yeah.
Can you understand the class variable and the difference between class variable and instance variable?
Yeah.
Okay, let me ask you a question, okay? Pretty simple question. So now I actually have a bank, okay? Bank account. So bank account is a class. So I create bank account BA1 and create bank account BA2, okay? So I have a data field. That data field is called balance. So is this balance instance variable or it is a class variable? Should it be static or non-static? Balance. You have bank account. You have bank account 1, bank account 2, bank account 3, several bank account. But there is a variable called balance. Is that a shared property or no?
I think so.
Yes or no?
Yes.
No, it's not. Say you have a bank account, I have a bank account. Your bank account balance is $100. My bank account is $3,000. So bank account 1 maybe $500. Bank account 2 maybe $3,000. So the balance will be different. Is that okay?
Yeah.
So balance is non-static. Balance is non-static. Is that okay? Does that make sense?
Yeah.
Okay, now I have a string variable. Then same, okay, same for you. So I have a string variable. That string variable is called address. So that's the bank address. So bank address, is that static or non-static?
Static.
Because your Citibank will be located in a certain location, no matter which account it is. Is okay? Does that make sense? So to determine whether it should be a static variable or a instance variable, it really depends on whether the data should be shared or it actually is individual copy. Individual copy will be a instant variable, so it will become non-static. If it is shared property, it should be shared. You should put the static before it. Does that make sense? Eileen, is that okay?
Yeah.
Okay. So let me ask another student, okay? Let me see, Eric Yu, okay, Eric Yu. So now let me change a different thing. So here now I have a class called student. Okay, now I have a class called student. So student here I create an object called, okay, Eric Yu, okay. I create another one, let me see, okay, William Lin, okay, whatever. 2 people. So now I have a new data field. I need to determine whether it's static or non-static, okay. This one is actually GPA, okay. So Eric, should GPA be static or non-static?
It should not be static.
Yeah, it should be personal data, right? So actually it should be instance variable, so non-static. Okay, so it's non-static. Okay, so there may be another one actually here. It actually can be, let's assume that actually is school name, okay? So let's assume this all students are from the same school. So now this school name should be a shared property, okay? But sometimes school name can be different. If you are in a club, school people may come from different school, okay? So let's assume that that's not the case. That's actually we have the whole thing actually only one school name. So that school name actually is a static property, okay? So here I just try to do some exercise to help you to understand what should be static and what should be non-static, okay? That's what I am trying to do right now, okay? Trying to give you the idea of what should be static and what should be non-static, okay? Okay, let's continue. Let's, okay, go back to our week 3, okay? So week 3, we go back to week 3. So week 3, we go over class and object, okay? I already go over the majority of the property in the class and object, okay? So basic, we have basic class and object, okay? So you have a class name and no argument constructor or one argument constructor. If you do not write anything, they'll give you a no argument constructor. Otherwise, if you write something, you will depend on which constructor you have, okay? You will lose your default constructor, but you can write it back, okay? And they are methods like get area, okay? They are methods like get area. So there is something called UML, okay, diagram. This one will not be tested, okay? This one will not. So a constructor with no argument is referred to as no argument constructor, okay? If no constructor is given, default one will be used. Default one is no argument constructor. Constructor must have the same name as the class name itself, okay, as the class itself. Constructor do not have a return type, not even void, so there's nothing will be returned, okay. Constructor are invoked using the new operator. So when you new operator run new, you create object in a heap in a dynamic area, and the address of that will be assigned to the reference. Okay, so constructor is used to instantiate an object and also initialize it. Okay. So here you can use a new operator to call the constructor, and the purpose is to build an object. Okay. And you can declare a reference variable. So reference variable is used to hold the address of a object. Okay. So for example, circle, my circle. My circle is a reference variable. Okay. It will be pointing to a certain circle object. Okay. It will be pointing to a certain circle object. Okay. This is okay. And you can access the data field by that data. But if the data is a private data field, then you cannot do it. Okay. So you can use a my circle, but the radius. But if the radius is a private data field, you cannot do that. You can only using the getter to get it. Okay. You can only use the accessor or getter to get it. Okay. And there are some method. Okay. There are some method you actually can invoke, but you need to use the variable name, that method name, to call the function. Okay. And if your data field you do not initiate it, you do not actually initialize it, then a string will become null. Okay, a string will become null. This one is very important. Null pointer is very important. Null pointer means that I have a string name, but it's pointing to nowhere. There's no object being built, so you will put null in there. So you will assign null to it. Okay, so if you do not assign value to a string, it will become null. If it is null, and you try to do name the character at 0, then you will have the null pointer exception. So be careful. When you use a reference data type, you also need to check if the reference is null or not. If it's null, then you cannot do it. Okay, you cannot do it. You have to get some value to call function. Okay, and if your integer will be set to 0 if your type you do not assign value to it. Your Boolean value will be set to false if you do not assign value to it. Your gender, okay, is actually a character M or F. Then you will be assigned with a character 0 to it if you don't assign value to it. Okay, the null value, male value, we talked about it already. Okay, so these are different data fields. So we just keep it method. Okay, so each function we call it method. The method may have a visibility specifier. Okay, public, private, or default. Okay, and you may have a return type. Return type is what type of data you will return. Okay. And then you may have method name and parameter list. So remember that the method and the parameter list, we call it signature. Okay, we call it method signature. So we use the method and the parameter list to determine whether they are the same function or not. Okay, so basically let's assume that, okay, let's assume that we have a maximum function. Okay, we try to find maximum. So this maximum function would have an integer A and integer B. Okay, this is one maximum function. There's another actually is actually double A and double B. Okay, these two are considered to be two different functions. Is that okay? These two are considered to be the two different functions. But if there is a maximum function, it actually called integer x, comma, integer y. Sorry, these two considered to be the same function. Because we only check the type, we don't care about the name. Is that okay? If you have a function of the same method name and different also same data type, and the number of parameters also the same, we call it TwoString Function. But if you have the maximum integer A, integer B, and you have maximum double A, double B, these two are considered to be two separate functions. Any question about it so far? Any question? Okay, this one very important. Okay, this one very important. This one, if you have a function that deal with integer type, also deal with the double type, we call it overloading. We overloading the responsibility of maximum, so it can deal with integer, also deal with double type. Okay, this we call it overloading. Okay, so that's the overloading of a variable. Okay, so there are several types of constructor. Okay, so every function has a function header. Okay, including accessor, return type, method name, and parameter list. And you have constructor. Constructor do not have the return type, not even void. Here you cannot put a void here. No, it's only used to build an object. Put a public. Okay, put static. No, you cannot put static over there. Okay, you cannot put static over there. So this is the constructor. Okay, constructor is used to build an object. Okay. Okay, it's okay. This one okay. Then assessor is getter. So get balance. So assessor is a public method that access a class object without altering the object. Okay. So you get some data, it's called assessor. Mutator is a setter that will update the data. Okay. So something like deposit and withdraw. Deposit and withdraw that will change your balance. These two functions are considered to be mutators. Okay, so these are mutators. So static method versus instant method. So usually static property, static method or static variable, it is a share function. It performs operation over the whole entire class, not only one object. We call it static function. Okay. If you actually only deal with a single circle or single bank account, then those kind of function, we call it instance function. Okay, so this is the rule how to determine whether it's a static or non-static. Static, sometimes we also call it class method. Okay, we also call it class method. So this is okay. Okay, so one thing. Okay, one thing. I'll go back to our program. So right here we have a test point, right? We have test point. So here, if I copy this, at this moment, we can call this test point as driver class, or we can call it tester class, or we call it a client class. Okay, these three names all okay. It doesn't contain the data. It doesn't contain data. It only testing other people, and the other people. This point class is right now is actually pure data class. So there's no main function. No one will test it. The only data. Okay, the only data. So right here, this one, this class point is a class, and it create different point 1, point 2. Okay, and you use a different class called test point as a driver class to test it, to test your class and objects. Okay. But you can also build in the tester, the main function inside your class as well. So you can put the main function into your own class as well. That's called self-tester. So usually when you see a class that has the main function, that's because you can do self-testing. Okay. So let's copy the main function from this test point. Copy it, okay, copy, and directly pasting it to the end of this point class. Just pass it, okay, pass it, and we directly run. Do nothing, just run it from point. And it's still working in the same way, okay? So here we can put on the first line, we can put the first line from self-tester, okay? So this whole thing is actually from the self-tester. So you can do testing from self-tester, or you can do testing from a test driver class. Is that okay so far? Natasha, is that okay so far?
Yes.
Okay. Any question, must let me know, okay? Unless otherwise I may go too fast, okay? Sometimes I may go too fast because I assume that everybody just know it, okay? So here, as you can see, originally my point class is very small. Now I have almost everything in there, okay? Almost everything in there. So that's to how to build a class bigger and bigger, okay? Okay, that is a class, and you have static method, okay? So I talk about the difference between static function and non-static function already. So a function of same signature, we call it overloading, okay? We call it overloading. A different signature, okay, different signature. Same name, but different signature, we call it overloading. So here we have product dealing with integer. We may have a product dealing with double. We may have product dealing with two integer. These three, we consider them to be three different functions, okay? These three, we consider them to be three different functions. So that's the overloading of the function, okay? So, but we do not care about the variable name. We only care about the type. It's called type matching. Your function will do type matching to determine whether there's overloading or overriding, okay? Scope. Scope is the lifetime of your variable and method, okay? And this one also very important, okay? This one also very important. That's actually called scope, okay? So let's look at the scope, okay? Let's look at the scope of every different variable, okay? Let's actually go to here, okay? Let me create a new one, okay? So let me create a new one. Let's actually get this one circle, okay? So let me have a new circle class over here, okay? And I'm trying to use this one to explain what is scope, okay? So basically here I may have a constant. So I write a circle class, I have a constant. So this constant is final static double pi, okay, equals 3.1415926, okay? So that actually is my pi. So this one is a constant, right? This one is a constant. It is a constant. It is also a static variable, okay? A constant means that after you assign it, you can no longer change, okay? That's called constant. Second one, I may have a private double radius, okay? So this one is an instance variable. Let's assume that it's actually 0.0 right now, okay? So I will have a circle constructor, no argument constructor, and I will run this and then put a 0.0 over there, okay? And then I don't have the constructor yet, so I write a circle, okay, with one argument, that's actually double R, and the R I will assign to the third radius, so radius equals R, okay? So this one is my circle. Then I have the getter, so I have public, okay, double, okay, get radius, okay, get radius. Okay, so this one I'm going to return radius, okay, return radius. I may have a second function called public, okay, void set radius, okay, set radius. This one I will set my radius. So my radius equals R. So right here I need to provide a variable. It actually is double R, okay, and then I may have a derived data field. So public, okay, double, okay, this one called get area, okay, get area. So this get area will return you the pi times radius times radius, okay. So this one is my get area, Okay, and then I also need to override my TwoString function. Okay, I also need to override my TwoString function, and this TwoString function will return, okay, return actually circle, okay, and then here I would have a percentage 0.2f, okay, and here I will use a string.format. Okay, this one is to provide formatted string and comma radius. Okay, this one will create a TwoString function. So here I have a data class right here. Okay, now I'm going to have a main function called public. Okay, static void main. Okay, so here I have this one args. Okay, here. So now I'll create a circle array. Okay, clist equals new circle array of 5. Okay, of 5. So at this moment, I only create what? I only create an array of 5 circle reference. So these 5 circle references are put null, 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 and null. And this one actually is pointed by clist. So clist is a reference to an array of 5 circle reference. At this small point, I do not have any circle at all. So right here, I may do clist2 will be equals what? Will be equals new circle. Okay, 2.0. Okay, 2.0. Let's assume that we actually create a circle only for C2. Okay, only for C2. So right here, I will do import. Okay, java.util .arrays. Okay, I imported .arrays. So before I print out the C2, I assign the C2. I do array.toString. Okay, clist. So I convert the clist to a string and print out. Okay, and after I create the clist, I actually also print it one more time. Okay, so let's compare these two values. So first one is null, 5 null pointer. After you create this, you just create 5 null pointer. You just create 5 null pointer. Okay, so 5 circle pointing to nowhere. That's what it is. Okay. And after that, I create a circle to C2. So only C2 being assigned with a circle. Other 4 still null. Any question about this one? Any question about this one? So one simply important here is that you create a circle object array. That means that you have a circle in the array. It just means that you create 5 reference. Is that okay? So right now only the number 2 hanging the circle there. Other 4 then now no one has the circle. Is that okay so far here? Any question? This one is not very straightforward, okay? Hi, James Lee. James, are you okay?
Yeah.
Can you understand this one?
Yeah.
Okay. So that is when you create an array. You only create an array of reference, okay? It doesn't create an array of 5 objects. You just create a new object hanging to there. There's only circle 2 got the data. Okay, circle 0, 1, 3, 4 doesn't get any circle object. No, you don't. You don't have object yet. It just build a room for you. It just build a storage room for you. So creating an array is just creating a container of the board. It's just creating the container of the circle board. Okay. And then right now, only number 2 really put a base keyboard there. Is that okay? Only number 2 has 4 there. The other 4 doesn't have any ball, but the box, the cabinet have been built that can actually take 5 balls into there. That's you are building a cabinet, but right now only 1 ball is put into the number 2 box. Only 1 ball in there. Is that okay? So must understand this. Okay, must understand this. So this is array of object. Okay, so here we create this. Okay, so now let's look at the variable. So right here, if in my function right here, I may have an integer a. Okay, this integer a is a local variable. Okay, so this integer a, when I call the main function, it is a local variable. This local variable will be in the call stack. It is over here, there's an a and it's put a 0. And it's under a call frame. This call frame is called main function. Okay, that's as soon as here I print out a. I print out this a, so this a is actually 0. So this a actually is a 0. Okay, so this a equals 0. Now let me actually print this a at the very end of the function. Okay, and right here in the middle, after I creating the circle, let me call a function called f function. And f function, let me actually pass a to it. Okay, let's don't pass a to it. Let's just call the function f. Okay, so this function f is actually public. Okay, static. Okay, void. Okay, f function. So this f function, I have created an integer a equals 100. Okay, and right here I actually print out the a. Okay, so I print out the a over here. So what will happen is, let me run it. Okay, so in the middle, the a become 100, and then you come back to your main function, you go back to 0 again. So what it is that when we call the f function, you will create a call stack. And then a will be showing up there. There will be a 100 there. Okay, this one is belonging to f function, and f function the call frame in the stack. You temporarily store it. Okay, so in the beginning, when you print the first time, you print this a, that is this yellow copy. Yellow copy, you print out 0. And then you go to f function. So f function, calling this f function, you print out this pink one, so you print out 100 in the middle. Okay, and then you return to the main function. And the main function, again, you print out the yellow copy. So this yellow copy A and the pink copy A, they are totally different A. They are stored in 2 different call frames. Is that okay? Any question? Any question? No? No question, okay? No question is good. So remember that this is local variable, and this local variable, the life scope of this one is from this where it declared to the end of the function. Okay, so this one a is from here to the end of the function. So that's the scope of this variable. But here, if you do have a variable, say integer g and integer h, okay, these 2 variables, the scope will be from this parameter to the end of the function. Okay, will be from there to there. Let's put some 2 and 3. Okay, just to avoid the error. Okay, so that is parameter function. So integer G, integer H, integer A, and the integer A here, they are all local variables. They are all local variables. And local variable have its life scope. So this A will be starting of its declaration to the end of the function. G and H will be starting of the function to the end of the function. Okay. Okay, these are actually the so-called functional level variable. So sometimes you do integer for integer I equals 0, I less than 10. Okay, I increase. So this I actually is available from the starting of your loop. From starting of your loop. So there is a I equals 0 and do one iteration, go back, I become 1 iteration, then I equals 2. And then keep doing until I equals 10, you get out. So the life of the I keeps 0 iteration. We call this I as loop level local variable. Okay, we say this one, this I is a loop level local variable. Is that okay so far? So if you try to get from outside, you try to say system.out.println. This side, sorry, outside you don't see it. So this one is not okay. Okay, outside you cannot see this I. Here you may have another variable, so integer b equals 10. So this actually this one is a so-called block level variable. Okay, this one only lives for 1 iteration. So this one life is even shorter than the I. I is actually several iterations. So I variable is starting from I equals 0, 1, 2, 3, 4. So it have many iterations. But this B actually, when I equals 0, there's one B. And then second time you actually I equals 1, you have a second B. So the blue B and yellow B are actually different B. And third time when you have I equal 2, you have another B. So blue B, watercolor B, and pink color B, they are totally different B. So each B only lives from where it is declared to the end of the function. This one we call it block level variable. Okay, this one we call it block level variable. So here I'm trying to explain to you what is local variable, functional local variable, what is parameter variable, what is loop level local variable, what is the block level local variable, and what is instance variable, and what is static variable. Static variable will be there always, not even before, you don't need to create any object. The constant is over there. So you use a circle, the pi, you should be able to access this variable. So this one, static variable is static, okay, never move. Okay, never move, okay? So is this when class got loaded? When class got loaded, you already have that variable. That's called static variable. It is not stored in heap. It's not stored in stack. It's stored in the global constant pool. Okay. So there are 3 storage areas. One is a heap. Heap is used to store object, or string. Okay. Call stack is used to maintain the main function, F function's local variable. And then there's another one called constant pool. And that you do not even need to create object or create a call function. The pi is always there. It's static, never move. Okay. Any question? Hello, any question? Any questions so far? So here we explain 6 different types of variable, okay? Static variable, instance variable, okay? Parameter variable, functional label variable, loop label variable, block label variable, okay? 6 different types of variable. You must know about when it will be alive, okay? So when you answer the problem according to its lifetime to answer, okay? According to its lifetime to provide answer. So that is the life scope of your variable, okay? So the property of the class. So the property of the class. Property of class means that you need to know about the local variable of different kind, okay? Local variable of different kind. And also need to know about the static variable. Static variable is static. Once your class can load it, you will have a class variable. That's called class variable. And you also have instance variable. Instance variable belong to certain object. Okay. Then you have local variable. Local variable including the argument variable or parameter list variable. Okay. That's showing on your method. And you have the functional label variable. It belongs to a certain function. And then you have for loop variable that belong to a loop. And you have the block label variable that belong to a certain code block, okay? So your instance variable is actually the whole class can see, the code class can see, okay? Your parameter variable, the whole function can see. Your local variable, only the block that it exists in can see, okay? So here we have a static function called square root, okay? So this square root is a static function, so it provides to calculate the square root function, okay? So here we do have what? In the main function, we do have integer n. Integer n is an integer, okay? So this one only available in main function. And we have the double A is new double. So A and n in the square root function, you cannot see it. You cannot see it, okay? That's different function in different code frame, you cannot see, okay? And for loop, you have I, and I actually is what? It's loop variable, label variable, okay? It will exist when the for loop existed, okay? So also look at public variable, you can see it at any location. Default variable, actually same package or same class. Private variable, only same class, okay? So this one's okay. Immutable object means that a class that you do not allow the object to be changed. This one string class is actually immutable, okay? So you can only create new string, but you cannot change the content of the old string. We call it immutable object. An immutable object has 3 rules. All private data field, no mutator and no accessor method returning the reference data type. Okay, these are the requirements for the immutable class. Okay. So encapsulation. So private data field, you need to use a public method to get it. You cannot use the dot access to access it. Okay. So this one we skip it. Okay. Okay, reference. So we have pre-match data type and reference data type, okay? And we talk about it, that's the first question we have today, okay? And must remember what are the difference between them, okay? This reference type and null type, we also talk about it already, okay? Okay, method parameter, okay? So you can have formal parameter and actual parameter, okay? Formal parameter means the variable list, we call it formal parameter. Actual parameter means that you withdraw password string 1111, that's actually is actual parameter among $1,000. That actually actual parameter. Okay, so actual parameter is the number you really call, the number you pass into a function. Okay. Okay, so all of the function code, when you are pre-match data, you only have the code by value. So only the value of the x will be passed to this x variable, okay? So you call full AB. Full AB actually is 7 being passed to x, 6.5 being passed to y, okay? And then AB is detached from xy, totally no relationship, okay? So you update your x and y, the outside when you print it, still 7 and 6.5, okay? No change. Okay, so when you pass the object to the parameter, this one will be more tricky, okay? We'll explain it when we see the problem, okay? So here we have different examples. We will see it when we see the problem set, okay? Okay, this, I think this one are okay. Okay, so that's actually, right now we are 7:46. Okay, let's come back on 7:52. We will start to look at the problem set for week 3, okay? Hello, any question so far? We are back. Any questions so far? Hi, Amy, any question?
No.
No? Yeah, okay?
Yeah.
Okay, in between the break, I actually upload the file, this parents chapter 3 is a PDF file. Please download it, okay? Today I was just started from Amy, okay, the problem 1. Can you work on that one?
Yeah.
Try it, okay? We are discussing, okay? So no pressure, okay? Don't feel pressure. So here we have, so then next one is Damon problem 2, okay? And then Eric Yu problem 3, okay? So question 1, okay? We are given a time class. So which of the following statement is false, is wrong, okay? Which of the following is wrong? Tell me which one is wrong.
Is the answer D?
Why is D?
Because they're not accessors, and increment wouldn't be considered a mutator. And I don't think.
No, the answer is D, Daniel, D.
Yeah, I said D.
Yeah, and why D?
Because there's one at the beginning.
So how many constructor?
There's 3 of them.
No, actually say which one is wrong.
Oh.
So D is wrong. D
Yeah.
is, the answer is wrong. But why is wrong?
Because there's 2 constructors, not 3.
There are 2 constructors, yes, there are 2 constructors. They are only time no argument and time 3 argument. That's it, only 2 constructors, okay?
Mm.
So 1 is correct because equals less than TwoString. They are all accessor. They are not going to change data, okay? So TwoString less than and equals, they don't change data. So they are accessor, that's right, they are getters. Increment is a mutator. Yes, you will increase the second. Okay, that's right. Time no argument is a default constructor. Yes, that's a time no argument is default constructor. Okay, D is wrong. There are only 2 constructors. Last one, there's no static method in the class. Yes, there's no static method in the class. Is okay? So only D is wrong. Problem 2, Damon win. Okay.
Is B.
It is B because you kind of assigning the parameter to the instance variable. Is okay?
Yeah.
It's assigning that. Okay, that's the reason. Problem 3, Eric U. Okay.
It's D, 2 and 3 only.
D, 2 and 3 only. Okay, so right here, one key important is essentially in climb class.
Then it's 3 only.
Okay, why one is wrong?
Because it's a client class and it's creating a new object, but the instance variables H, M, and S aren't existing in that class.
That's one thing. HMS is not is it. Number two is that you are processing the T, you do not need to create a new T. Okay. And print T is a class, T is not available. So this is totally wrong. Is that okay? So these are many wrong. HMS now there. Okay. Second, T, okay, T is actually is available. That's okay. But actually you do not need to create a new T. Okay. This new T has nothing to do with the little t. These two are different objects. Okay. Second one is wrong because this actually is private. You cannot use that. Is okay? Hello, Eric. Is okay?
Yeah, it's okay.
It's private. Private you cannot use. You have to use a getter to get it. But do they have a getter for there? No, they actually don't have getter. So you cannot use that, even no getter. Okay. Why 3 is correct? Because many of you may look at the book, just give me the number. Okay, you are not. You actually try to use D, but some students just look at the book. So why 3 actually is correct? You have to know why. Cannot just actually picking at the book. It doesn't count. Okay. So why 3 is okay?
3 is okay because it's printing out the value held within the time object.
Why? Why you will?
Because of the TwoString.
Yeah, because of TwoString. That's the key word. You must say it. Okay. Because when you you print the reference automatic will call the TwoString function. If you don't have a TwoString function, you print out time at some address location. Then it's not right. Is that okay? Good job. Okay, good job. Now number 4. Let me have Henry. Okay. Wait, Henry go to restroom. Okay, how comes that go to Harris? Okay, next one, James D. Which one is false?
C.
Why C?
Because I'm pretty sure in order for the constructors to overload, then they need to have the same names, unless I remember wrong.
No. Overloaded do not need to have same name. No, that's wrong.
Oh,
So I
it's
don't.
the one that's about that. Then
No. Why C? Why not B or A or different one?
would it be? Would it be E?
No, the answer is
No,
C.
E is true.
The answer actually is C. But why C?
I'm not sure.
In the class, actually, I emphasize many times, we only check the type. We only check if the integer, we only check the type. We don't care about the name. When we check if it's overloaded, we have integer X, integer Y versus integer A, integer B. These two are considered to be the same function because we only do type checking. We don't care about the name. Same name AB is actually not allowed. It's actually considered to be the same function. XY actually also the same function. Okay, so different name did not differentiate the two functions, still considered mutable set, must be different type in order to be considered to be overall the function. Okay, so don't just look at the answer, try to know what it is. Okay, number 5. Number 5, this one, let me see. Look ma, okay, look ma, number 5.
1 sec.
So here you're given a class like this, okay? I actually put the PDF on the chat box, okay?
Yeah, I'm reading it now.
Yeah.
What's the date object? I'm going with. How about B?
Okay, let's look at A. What's wrong with A?
Well, it doesn't specify the object type. It just says
Okay.
new, and yeah.
There's no class name, okay? That's good. What's wrong with C? C also no object name. So basically,
Yeah, same deal.
so
And
A,
D.
what's wrong with D?
D doesn't have the new
And
keyword.
E also don't have the new, so this wrong.
Yeah.
Only B can keep. Okay, good job. Number 6. Okay, number 6. So number 6 also based on that. Okay, this one lean pen. Okay, lean. What's wrong? Which one is wrong, or how many wrong here?
I think because only number 3 is wrong.
Why number 3 is wrong?
Because it also calls one of the method inside. It's like, but it's kind of, there's no, it's like no, like a new, and then you code a method.
Yeah, it's actually null pointer exception. Is it okay?
Yeah.
You have the null. This one pointing to nowhere. So your date reference is parking. Parking means that it's not pointing to object. So there is no year function to be called. Right. So that one is wrong. So number 3 on this one. Okay. It actually you have nowhere you can call. Okay, you have nowhere you can call. So let's see. Number 7. Number 7.
Oh,
Yes.
actually, I'm a little confused about 6. Wait, so you're saying there's no way that the year method can be called with how 3 is implemented? Oh, wait, right, it's null. Never mind. Sorry.
Yeah, okay. But why 2 is okay? Why 2 is okay? 2 D1 is parked. D2 also being parked. Okay, so no 2 parking car is okay. You know what I'm saying? No one care about parking car. Okay. So number 7 that we have Natasha. Okay. So which one would be wrong and why? Number 7.
Is it E?
Why E?
I'm not sure.
It's a private data field. We cannot use year. Year actually is a private data field. So private, you cannot use a client class to access it. Is that okay?
Okay.
Okay. So that here is actually computing right function. Okay, not this one. Okay, actually here. Okay, so actually a client program create an object. So client you cannot use. If it's like number 8 is added to the class. Added to the class means okay. Okay, number 8, this one, let me see. This one for Oscar, okay? Oscar, how about number 8?
It should be A.
A.
Yeah.
This one actually answers all of above.
Oh, wait.
You are in the same class, so data field okay, calling function okay, TwoString also okay. Does that make sense?
Yeah.
Data field okay, calling function okay, TwoString also okay, 3 all okay. Okay, must know it. Okay, if you just trying to get the one answer, you may be wrong. Must make sure that you really understand each individual one's detail. Okay. Number 9, let me have William Dean. Okay. Okay, please download. Okay, here we have 1, 2, 3. So which one is okay? Which one is not okay? 1, 2, 3. So William is number 1. Okay.
I didn't do it because I didn't go last class, so I didn't know we're supposed to do this.
You didn't go last class. This we actually covered today.
Oh. Well, I didn't do it, so.
Yeah, but you work on it now.
Yeah, I am.
Make sure pay attention to the lecture. Okay, we discussed it the whole day today. So must study the weekly material before class. Okay, also return the related homework. Okay, and in the class, we will work on this each weekly review for parents together. Okay, to help you to learn what is the problem solving skills. So how about 1? Is 1 okay or not okay? Is 1 okay or not okay? Hi, William.
Oh, I don't know.
You don't know? 1 is okay.
I haven't done it yet.
Yeah, 1 is okay.
Wait, just to clarify, are we supposed to do like this week 2 assignment one like the week before the class starts?
Yeah, you study, you can do it, yes, but we do not need you to return.
Oh.
Yeah, I announced it on the first week. You are responsible to return what? You are responsible to return the assignments. So weekly review here, I told you we are going to discuss it. We are not going to need you to return. Only each week you need to just return the assignment. Now, no problem if you are confused, it's okay. We don't blame you. So remember, you just need to return the assignment portion. Is okay?
Yeah.
So right now we are actually discussing this week 3 part, okay? After the class, I teach the whole class and we are trying to discuss this. So why 2 is wrong?
Are you still asking me?
Yeah, I'm asking you, this is your problem.
Oh, I'm not really like caught up on it.
But it's very obvious. You should read it. What's wrong with this one? This one is very obvious. Number 2 is wrong. It's very obvious. Anybody know? About Amy, what's wrong with the number 2? Let me ask a different student. Amy Chow, are you okay?
Yeah.
2 is wrong. Why?
Um,
Don't feel pressure, okay? We are discussing, we're just discussing. Yeah, why 2 is wrong?
wait, can I see the parameters that it takes in again?
Parameter,
Yeah.
you mean here?
Oh, it doesn't.
It doesn't give you anything,
Okay.
but 2 is wrong. But 2 is wrong is very obvious. Can you do this? Can you do calling a function equals 3? Can you do that?
Oh, no, you can't.
Yeah, so it's pretty obvious. How can you declare a variable called function and accept
Yeah.
data? That's for sure not okay. It's even not even a problem. Okay,
Yes.
it's even not a problem. Okay, number three, this one, number 3, this one, number 9. Number 3 is also wrong. Okay, number 3 is also wrong. Let me check another one. You, what's wrong with number 3?
Sorry, I was lagging and didn't hear what you said.
Number 9. Number 9 is the number 3 part, this portion. Why this one is also wrong?
I think number 3 is wrong because it's trying to directly modify the instance variables in the class.
Yeah, this making no sense. How can you declare a variable that's actually an object X? You try to declare a variable for object X, right? Making no sense. So 2 and 3 actually is no brainer. No one writes program that is in Java. Okay, so this automated wrong. These 2 automated wrong, you can only be one. One must be right. One cannot be wrong. Okay, so you actually do integer and then get data to it. So normally it would be like integer m equals input dot next integer, something like that. It very likely is something like this. Okay, so you read a integer to the variable m. Okay, function cannot be put on the left hand side. Okay, and you cannot declare a variable using the function name. That's totally making no sense. Okay, and data field can also not be put on the left hand side. It actually totally making no sense. Okay, it's also making no sense. Okay, so now let's move on. Okay, this one number 9, number 10, let me see. William Zai, okay, number 10. In a way, I don't care whether you are right or wrong. Okay, I care whether you know it or not. Okay, we are reviewing. We are not actually just trying to get your score. Which one is wrong? Actually, which one is wrong? So you say the same method now create a second date object D2 is an exact copy of the D1 referred to. So D1, okay. So D1,
I think it's 3.
3 only. Let's look at it. Okay. So basically, D1 actually create object, right? Okay. D1 create object. So number one's way actually you assign D2 to this one. So it's like this. Is okay? This one is number one's way. Number two's way is over here. Your D1 still creating an object, you pointing to it, right? And your D2 try to create a new object. So it's something like this. But the data, let's assume the data is the same. Okay, data contains the same. So number 3's way, also D1 create an object, D2 also create an object. Okay. So it also this way. So who is wrong? 2 versus 1. Of course, 2 is right. You cannot pick 2, right? So actually the answer is A. A is wrong. A is wrong because it's what? It say that second object. Hey, here you only have one object. You do not have second object. Do you have second object? Do you have a number object equals 2? Do you have a number of object equals 2?
No, you don't.
No. So that's why in the middle, I actually tell you my function is very important. Okay, I'm not kidding. I come here and then actually here, actually in the class of the point, I give you the number of point. Okay. In the middle, I try to keep the example. It's all relevant. Okay, all relevant. What I'm trying to do actually is all relevant. I did not create something that's irrelevant to the test. Okay. So here you have an integer number of point. Number of point equals 0 whenever you call the constructor. Whenever you call the constructor, your number of the point increase. Okay, so only when you call the constructor, your number of point would increase. Right here, same thing. Second object. Wait, you only assign the reference. Is there a second object? No, it is pointing to the same object. Is that okay? Same data, but it's actually pointing to the same object. So
Okay.
Contains the same, but it's not second object. Sorry. Is that okay? So it's no second object. So one is wrong because of that. Okay. So here I emphasize one more time. I don't care about you pick the right one or wrong one. I really care about whether you study it or not. You really know it or not. Okay. Because we are reviewing. So number 11, let me see, go back to Amy, okay? Okay, which one is correct, okay?
C. Because recent date is set to null and then it's called again and adds century, but its value is null.
Okay, that's actually draw the diagram to show you, okay? Yeah, the correct answer is that one, okay? Let's try to draw diagram. So right here you have all day. So, okay, so your all day pointing to 113, 1900, okay? So that's your all day. Then your recent day actually is null, so pointing to nowhere, right? So you put a null to your recent day and the all day reference there. So basically your old is pointing to here, okay? And your recent got a null. Your recent got a null, okay? Your old is actually pointing to there. And all year actually is update 18 for 100 year. So 18 for 100 year means this one jump to 2000, okay? Jump to 2000. And recent actually assigned to old. So recent pointer also assigned to year. But outside recent date, no change. No change means it's still null pointer. Is that okay?
Yeah.
Is there any null pointer exception strong? No, there's no null pointer exception strong. All object remain unchanged. No, all object update to 2000. So wrong. Recent date refer to the same object. No, it actually is null. It doesn't change. Recent date refer to separate object. No, it doesn't. It actually is still null. Is that okay? So must draw the diagram to show what it is. Okay, you will know better. So here, let's see number 12. Okay, number 12. Damon Wayne. Okay, Damon. Which one?
It's going to be B. Since
Why B?
that's the only one that's like not set for like individuals, since all of the others you can get for like individual.
Tongue pen temperature. Everybody swimming in the same pool. Everybody got the same temperature. Is that okay? So that one is a good candidate for the class readable, right? Everybody swimming in the same pool. Okay. So yes, the answer is B. Okay. Number 13. Let me have Eric Yu. Okay, Eric. Number 13. Eric, hear me?
Yeah, I'm working on it.
Yeah. Yeah, you need to trace a little bit on this one. Take your time, okay? Don't worry, no rush.
Is the answer E?
E, boy?
E.
Yeah, the answer is E. How can you pick E?
When we call the method, it changes 8, the value x to 9 and y to 27.
Mm-hmm.
Then I don't think method changes the values of a and b directly. So.
Yeah. Okay, the key point is here, okay? The key point is that you just copy the 6 and 3 over here. So whatever x, y doing here, no change for AB, okay? Is that okay? No changes for AB, so you already know that second printout would have 3 and 6, 6 and 3. So only E has a 6 and 3, you can already pick it. Is that okay? Is that okay? You pass by value, your 6 and 3 pass to SY. So SY do whatever they want to do, nothing to do with AB anymore. So AB, when you print it, it will be 6, 3. So second line must have 6 and 3. Okay, let's look at the SY if you really want to know it. Okay, it's okay. Your X start to have 6, Y start to have 3, okay? So X plus equals Y, so X become 9. Y times equal X, so Y become 27. So eventually you print out 9, 27, and 6, 3, okay? Okay, now number 13. Number 14, let me have Henry, okay? Henry, your turn. Number 14 is actually a group problem of rational. Let me talk about rational number first, okay? Rational number is that you have a rational number such as 2/3, that's a rational number. So rational number usually have a numerator and a denominator, okay? And sometimes you may have 1/3 plus 1/6, you become 6, okay? 2 plus 1, it becomes 3/2. Then you need to reduce to 1/2. So there is a one reduced function, okay? There's one reduced function. So here, rational class is used to deal with the rational numbers, okay? Rational number. So now the question is, number 14, why reduce is not a public method? Why this reduced function is not a public method?
I think the answer is C.
You don't want people to use it, okay? You don't want people to use it. Okay, number 15, okay? This one go to James Lee. Which one is the answer?
Which question?
15.
15. Is there a code that goes with it? I haven't gone to this question.
Yeah, you check, you just read it.
Okay.
The PDF I gave you in chat, you just look at it.
Is it B?
B, boy?
Yeah.
Why boy?
Because R1 needs to be defined as a
assuming that R1 is defined. So B is not a problem.
R1, okay.
Yeah.
Then.
So you have to look at your rational constructor. So your constructor has no argument, 1 integer and 2 integer. You have 3 kind of constructor. So A, C, D, E, which one is not included? No argument, 1 integer and 2 integer. Which one is not included?
D as in dog.
D, no.
Because it's a double.
No double type, yes. Is that okay?
Yeah.
Okay, number 16. Okay, number 16, this one for look ma, okay? So what is number 16?
One second.
Take your time, no rush.
I'm going with D.
Why D?
Creates this new rational.
What's wrong with A?
Well, it doesn't have the new keyword. It doesn't set it equal to a new
There's
rational
no
number.
keyword, there's no reference, so A is wrong. What's wrong with B?
Actually, I don't think anything's, well, it doesn't reduce the new.
It doesn't
rational
reduce.
number.
Okay, B is wrong. What's wrong with C?
Well, C, that reduce, it's not calling it on the new rational number because it doesn't exist yet at that point in time. It's just calling it on the thing they're currently adding the R2.
The reduce will reduce the current value. It doesn't make an effect on the numerator and denominator that you calculate.
Yes.
Okay. So it actually, for example, you are working on, say you are working on the example I gave. Okay. You have 1/3 plus 1/6, and the answer is 3/6. Okay. So basically, this one very likely is actually operating on this one, and instead of reducing on this one. So you need to recreate a new rational number and then reduce on this one, drop to 1/2. Is that okay?
Yeah.
Make sense? And D is wrong actually.
What?
Why is wrong?
Oh, wait a minute. Yeah, D is wrong. It's calling it on rational. Not what I thought reduce. So it's, yeah, I read that wrong. It should be E.
Well, why D is wrong?
Well, it's calling the reduce method on rational, the word rational, which is the object type, and not this one instance of the.
It is not object type. Actually, it's not object type.
Oh no, not the object type. So wait, what?
It is not object type. Rational, it doesn't mean it's object type.
Okay, well, yeah, the rational class, it's just the same thing as calling the reduce method on the current value.
No, it doesn't. It's syntax error. Here the problem is that it's not a static function. It is an instance function. It's not a static function. So static function, you cannot use the class name that reduce to call it. It's the way you call it is wrong. Okay, so must understand the detail. Today I cover many things. Okay, this class method, I also call it class name that method. We go over the concept. Okay, it's okay. You miss somewhere, but remember to review it. Okay, remember to review it. This one is wrong because this reduce function is a private instance method. You cannot call it by the static method way. It is not a static function. On the other hand, if this one is a static reduce, then this one is correct. E is wrong. You have to pick the answer based on the function you have. Is that okay? You cannot say always E is correct, D is wrong, or D is wrong, E is correct. You have to determine the what function are you calling. This one is calling as an instance method. This one is calling as a class method. Class method, is that a class method? No, it is not a class method. It's not a static function. It's an instance function. So it's calling in the wrong way. That means that the function is wrong, okay? Number 17, okay? We check a lot of detail, okay? We check a lot of detail. Number 17, look ma, okay? Number 17. As I say, I don't care whether you are right or wrong. I really don't care. I care about whether you listen to the lecture or not. You really understand it or not, okay? This one, let me do it a little bit, okay? So look which one it is. Number 17. After class, you watch the video, you still have question you still can ask, okay? You can still send email to me or something. I will also reply you or even talk to you by Zoom or somehow. But try to understand it, okay? If there's something you don't know. You are reviewing for the test. We are not actually just want to get some answer from class. You need to make sure you know. That's a key point. Look, hear me?
Yes.
Okay, so what is the answer for 17?
I'm going with A.
A, what's wrong with A?
Well, the rational value A, it hasn't got anything in it, so it's.
No, you will have some default value. No argument, you will have some default value. So
it doesn't say what that is, though.
There is a default value. When you declare, they would be assigned some default. So what would be the default value?
Well, 0.
0, yeah, you get 0. Maybe you update it in the rational, but anyway, they will be 0, 0. But anyway, this one actually is not wrong. Compile wrong. Compiler doesn't wrong. It may have division by 0 wrong, but it's not compiler wrong. So A is not wrong. The one that is wrong is actually D. Your integer is primitive data type. Primitive data type don't have function plus.
Oh.
Got it?
Yeah.
Okay, so the answer is D. Primitive data type is not an object. Not an object, you don't have function. It's only a storage. There's no method associated with it. So this one can be D. Okay. So that's number 18. Okay, next one is number 18. Number 18 is for lean. Okay, lean, this number 18. So there's a temperature class, long, very long, and then come to this number 18 problem. So you read the problem, trying to draw diagram on this one. I'll give you more time. Okay, I'll give you more time. Number 18.
Sorry, who are you asking this time?
Lin Pan, okay, Miss Lin Pan. Did hear me?
Yeah.
Okay, take your time, okay? I give you more time. Don't worry, no rush. Are you okay?
I'm actually not really sure with this question.
You're not sure, okay? No problem. Okay,
Yeah.
let me check it. Okay, it's okay. You're not sure, okay? Because we are practicing. So, okay, number one, you have a T1. T1, you create an object that's a 40 degrees C. Okay, no problem. T2 pointing to the same object, you assign the address to it. Okay, T3 call a function T2 lower by 20. So lower by 20. So actually is T2's object's temperature drop by 20. You get 20 degrees C, but your T3 also attached to it. T4 is your T1 to Fahrenheit. T1 is here converted to Fahrenheit. So actually T4 also attached to it. So the answer is B. All of the four being attached to the same temperature and in degree Fahrenheit. Is okay?
I have a question.
Yes.
The answer says in degrees Fahrenheit, but isn't temperature T1 and temperature T2 and temperature T3 in Celsius?
No, they got updated. This one to Fahrenheit, change it already.
Okay.
The last one changed. Is okay? Because they share the object, they will actually update it, okay? Number 19, we have Natasha, 19, this one, okay? So we go over the detail of the class and variables, okay? With some reason, okay? That's why we work on the problem set right away. So this problem 19, which one is the answer? Okay, so basically you have a class, you get two inputs. So these two inputs is not hard. Basically, how to create a temperature with these two number you get.
A.
A is kind of okay, but you do not check the degree C and temperature scale. So you want to use the is valid temperature to validate it. Okay, you want to use the is valid temperature to validate it, and the two numbers are given. Okay, two data are given, but it's a static function. So by this static, we know that we call it, we need to call the temperature dot something. So basically, only B and E kept. Okay, so B actually you create an object already, you check the temperature too late. So it actually checking the temperature and then create a new temperature object. Is that okay?
Yeah.
So the answer is E. Does that make sense? So the first step, you must know that actually it's a static function. So static function need to use a class name that method to pick it, to check it. Okay. So that's a key point. The key point is over here. Number 20, okay, Oscar, please, okay. So here yes, question?
No, nothing.
Yeah. It's okay to have question, okay. Number 20 for Oscar, okay. What is the answer here? So basically there's a function called is Fahrenheit. So I think this one is added to the, will be added to the temperature. So how you convert a temperature from Celsius to Fahrenheit?
Would it be E in this case?
This one, the answer is 1 and 2 only. 1 is directly you use a degree time 1.8 times plus 32. So this one, okay. 2 is you use a Celsius temperature time 1.8 and create the object first, but you raise 32 after it, so you still get the same answer. So this 2 is also okay. Third one, your degree times 1.8, and this dot raise. This dot raise is current object raise. Current object raise is the degree, and the degree is what? Where is the degree? Where's degree here? We have a degree. So degree is a private data. Degree is a private data. Okay. And this one, new temperature. You assign this race to this. This is current object. Can you assign something to current object? If this one we don't have the, let's say, if this one we do not have this, we do not have this, then its current temperature got changed. But current temperature, we kind of would like to generate a temperature separately in degree F, not changing the, so this one will make your current temperature become 1.8 degree plus 32 Celsius. But you create a new temperature, but the current temperature remain in degree C, but actually the data is wrong. Okay, so only D is valid. It's okay? 1 and 2 are valid. Any question on this one? I ask her, is that okay?
Yeah.
Now let's actually move on to number 21. Okay, 21, we have const start, we have main function, okay, here. So this one, let me have the William Lin, okay, William, which is the answer. You'll get some results. So tell me what will be the result and pick which one. What will be printed and so given that value is 3, so basically you are going to print 3 times, print the count 3 times. So what will be the 3 value of the count after execution this code? We didn't hear me.
B.
B, boy.
No, D for dog.
Nothing. Why nothing? Why
It
undefined?
doesn't say in the do something method what happens.
If you don't
Wait,
know
oh yeah,
about
wait, never mind. I think B.
boy,
Yeah.
the answer is A000. Because this red counter and this green counter are different counter. So you do something, you mess up yourself, I don't know. I don't care. You calculate your count become 1 million. Nothing to do with my green counter. This one is local variable, only happen on do something for the red one. Red one only happen in do something function. The green counter just do count by itself. So it's actually 0, print 1 time, 0, print 2nd time, 0, print 3rd time is still 0. So the answer is A000. Okay. So this one is testing you the concept of call frame and local variable. I told you that when we call the call frame, you have some counter in the do something function and main function. This is very important. Okay, this concept is very important. Whatever I talk about today, all are very important. Okay, and it is the basic theory that you need required. You actually need them to answer the problem we have in this review problems. Okay, so if you don't get it, please watch the video again. try to work on the whole problem set by yourself one more time. Make sure that you really understand it. Okay, make sure you really understand it. Any question here? This one? William, is that okay?
Yeah.
Does that make sense?
Yeah.
Okay, so must know that this count is locally declared variable, so it will be start here, and then when you finish call, it is dead. This call no longer exists. So this counter outside the green one, it come to here. So do something, will call do something. So you will have different counter. It comes by itself in the red domain. I don't care. I don't care what it is. At the end, when we return to the main function, I still get the counter of the green color. That one I get 0, 0, 0. Okay. Number 22, we have this integer object. William Zhai, okay, William Zhai. So here you have some instant object description, and there's something, some measure. So what would be the final value for x, y, and a? So this one you need to draw some diagram, okay? Give you some time to think about it. William Zhai, hear me?
Yeah.
Okay, take your time, okay?
I really don't know. I'm sorry.
Okay, no problem. This one is not, you have to know how to draw it, okay? No problem. Let's actually get started, okay? So we start with the x. X is a reference to an object of 2. And y is an object of 7. So far, okay? And then a pointing to the object that y pointing to. So far, okay? We did say, okay?
No, I get it. I get it. I'm just listening.
Yeah. Then you pass your y to the function.
So they just all become the same thing?
Yes, they become all the same thing.
So
So
the A?
here, yeah, so here actually pass to the function. So your y pass to the function. So y's age is being passed to the function. So your ANS is also pointing to here. Okay. Then after that, your ANS multiply this one to A by increment. Okay. Going back, actually, you try again. You try again, your x being passed to the function. So your new ANS actually, your new ANS is what? I'm sorry, the return result, there's ANS, where ANS pointing to is US. So US will be pointing to here first, okay? After this one, you assign your ANS to US. So US also pointing to the same location. Then your ANS, actually your X assigned to pass to the function or object, assigning to a new ANS. So new ANS pointing to here now, okay? And this one multiply to 9, and then A redirect to the same object. So at the end, XYG, they all pointing to an object of 9. So the answer is AAA999. Is that okay? Is that okay?
Yeah, thank you.
So remember that, so if you still don't know about how to do this object diagram, please review the video and then try to work over the problem set and draw diagram, try to understand what is heap, what is stack, what we call it, okay? Number 23, go back to Amy, okay? You are the first person, so you have one more problem.
Okay. A is 6.
Mm-hmm.
Y is 8.
Mm-hmm. How about tab?
I don't think it's ever defined anywhere.
Okay, so here is like, in your main function, you have a call stack. So initially you have x and y, x actually is 6, y is 8, right? So that's your main function. So this main function pass 6 and 8 to A and B. So your some method have A and B. You copy the 6 over here, 8 over here. And these two guys actually do swap. So it becomes 6 and 8. But 6 and 8 remain over here. So 10 variable is also over here, okay? So 10 variable is actually should be holding the 6, but it doesn't matter. When you actually finish the function, the whole thing got pop out. The whole thing got pop out, so there's no frame anymore. So you get the SY only based on the original value. So SY no change, while temp no defined. So the answer is C. Is that okay?
Yeah.
Okay. So now we finish the week 3 material. Okay, next week we'll go to week 4 for the second part. Any question on this course so far? Any question on this course so far? Whatever review problem or any problem or any in general, any problem about AP Comsci A, you can all ask now. Any question? Any question so far? Any question you can ask now, no matter what it is. Any AP concept problem you can ask, okay? No question? Let me see, we have a checkbox, let me see. Let me see, okay. Will we get the answer key for the FRQ? Okay, multiple choice, I think we have that, okay. FRQ, okay, FRQ we can give you, yes, of course. Yeah, they are in public domain. We should be able to give you, yes. Okay. We should also be able to give you some video from other class for the review of the FRQ. Okay. Any more question? Any question about AP Comsci A? Okay, okay. Doris, have any suggestion so far?
I think no more. I think if everyone no more questions, we can see you next. See you guys next week.
We can be dismissed. Yeah, but I hope that students come out with question, because if you really work on the problem set, there should be a lot of question, right? Unless that you are actually perfect. Otherwise, you should have some questions. So please study harder, okay? If you actually try to wait until the last month, say April, to start review, I would say you'll be too late. I would say you'll be doing. That's why we set up a 10-week practice, okay? Usually my past years experiences that the curve will go like this, okay? Usually you need to go to the week 5 or week 6 before you pass 61 to 65. to be on the level of 5. Okay, usually it's something like that. You start with 44, 45, 55, okay, 58. Very few students start with 61, 63. Okay, very few. I would say very few. Only the kind of student who go to Harvard make that label. Okay, or Stanford make that label. I see some students before, but very few. Okay, before even review, or someone who actually participates some big user code competition. Okay, they will score very high, maybe 70 something. We do see some students like that before, but very few. Other than that, normal people start from maybe 45, 58. That's normal, but you take a while to pass week 5. Okay, if you score stay like this, it's no good. Okay, it's no good. We would rather you climb up. So if you start late, so you actually start like a week 6, week 7, you only have 4 weeks to go, it's too late. You will climb up only have 3-4 weeks, too late to climb up. So 10 to 15 weeks for any of the AP preparation is perfect. Too long, maybe 4 months, half a year, I think it's too long. So 2.5 months to 3 months, I think is a perfect time frame to actually ramp up your score. Okay. If you know question, we are up to here today. Okay. Thank you. Bye bye. Good night.
Thank you, guys. Please remember to turn on your assignment.
Thank you.
Thank you.
Thank you.
Okay.
Bye bye.
Bye bye.